Hey, what's up guys? Jeremy here from RoboDK. I'm super happy to host this live webinar today. Before jumping to the main subject, here's a few things you need to know about this webinar. First, the agenda will go a bit like this. I'll start by presenting some of the RoboDK's feature, then I'll do a technical demo on a few of these features, and finally I will answer your questions. Today's topic is CAD to PAT. So for those who may not know, CAD stands for Computer Aided Design. So CAD to PAT is a pretty broad topic, but we could summarize by saying it's a simple way to go from the 3D model of your part to a robot program that can be executed on your robot controller. This is in part why the founder of RoboDK decided to create that software to give robot users an affordable tool to easily create what would normally be challenging robot programs. And obviously being able to do so starting from the 3D model of the part you are working on. So CAD to PAT is not one single feature inside RoboDK. In fact, there's many features that could be included in this package. The first one being the Teach on Surface feature. Then you have the Curve Follow project, the Machining project, and finally all of our plugins for the CAD and CAM softwares. So if we go take a quick overview, of these features. So the Teach Target on Surface, or Teach on Surface, this is by far the easiest method for a RoboDK beginners. So you simply import the part either as a step file, IGES, STL, or in a few other file format. Then you activate the feature and you simply click wherever you want on the part to create targets that will touch the surface of the part. I'm not going to give you too much details right now on this feature because the live demo I will do in a few minutes will pretty much cover it all. So, and the small video you can see just right there is pretty much the demo we will do together in a few minutes. Okay, the next feature is the Curve Follow project. This is a tiny bit more complex, but it's so powerful once you get a good grasp of this feature. So quickly, this feature, as the name implies, will help you follow a curve on the part you are working on. So in the example just beside me, just right here, I've used this feature to create a dispensing program. The Curve Follow project is equipped with a lot of tools to help you in your project. So you can tools to help you manage the orientation of the tool along the path, automatically avoid singularities and joint limits, activate outputs at certain points of the program, like here for the glue applicator, for example, and much more. There's different ways to generate the path itself. You can extract it directly from the 3D model imported in RoboDK. You can import it from a list of points as a text file or a CSV file. You could have created that list of points manually, or let's say with a custom algorithm that you created. And you can also import it using one of our CAD plugin. So this is a super strong combo, but I'll give you more details on that in a few moments. Okay. The next feature is the Machining project. The Machining project is very closely related to the Curve Follow project. The menus, the options, and all are pretty much the same. The only real difference is how the path is imported. In the case of a Machining project, the path is imported from a CAM program or a machining program. So for example, if you have a CAM software and you created a milling project in it, you can generate your G-code-like file, so maybe an APT or NCI, for example, and drag and drop it to RoboDK to generate the machining project. Again, you can manage things like joint limits and singularities, but you can also manage tool change and spindle RPM if required. The specific example I'm showcasing here, the 3-axis milling, is part of a tutorial we released this week on our YouTube channel. So if you feel that you would like to take a look at it, feel free to do so after this webinar. This brings me to the last CAD to PAT feature of RoboDK. So our CAD and CAM plugins. Okay, so stay with me, guys. I'm almost done with the talking. Here, okay. So in total fairness, the plugins are not really feature, but more of a better way to import the path to RoboDK. So they pretty much create a combo between either the curve follow project and machining project and the CAD software you generally use. So plugins are small tools that we develop in some CAD and CAM software to improve the workflow from the designing software to RoboDK. So we already support quite a few software and we're constantly adding new ones, but here's a list of some of the ones we already have. So on the CAD side, you can find Autodesk Fusion 360 and Inventor, SolidWorks, Rhino 3D, and we are about to launch a new one in the near future. With this plugin, you can do many things. You can obviously import the part you designed in the software, but you can also import points and import curves. The nice thing about the curve importing the curve is the curves can either be the edges of your part, but they can also be 2D and 3D sketches. So this is great. Here's a small example on here's a small example of how it works. So if you have the part, you can select whatever feature you want to import, in this case an edge, but as I said before, you can be the part, points, or the curve. Then you import that to RoboDK. You can then manage the tool orientation, approach and retract movements, IO's activation, and other parameters. Then you generate the path and upload it directly on the robot controller to be executed just like this. This is a video I did earlier this year, so you can watch it back on YouTube if you want to see it more closely. And as I said, one of the great things about this feature is that considering that you can import 2D and 3D sketches, you can pretty much draw any path you want on the part in your CAD software and import it to RoboDK. In my opinion, that gives you a lot of flexibility to create some fancy robot trajectory. Okay, I'll just go back to the slide with the logos. We also have integration with some CAM software. Again, for those not familiar with the meaning of CAM, it stands for Computer Aided Manufacturing, pretty much machining software. The goal of the CAM plugins is to create a bridge between the machining software and RoboDK, a bridge that will automatically transfer the milling program to RoboDK, in fact. So at the moment, we support the manufacturing features of Fusion 360. We also support Mastercam and Mexsoft, and a few more that are not listed here. So if you go take a look at our online documentation, you can find the complete list. Keep in mind that you don't need to have these CAM software in order to create a robot machining program in RoboDK. Any CAM software would work here. These plugins simply gives you a faster and easier workflow. That's it. Okay, so that's pretty much round up what I needed to tell you about the different features. Okay, so let's jump to RoboDK. So here's our first station. It's a pretty simple one using a Fanuc M20 AI, a Mitre scan from Creaform, and a part that some of you may recognize from the Basic Guide series. So if you didn't have the chance to take a look at the Basic Guide series, I would highly recommend you to do so. It's available on our YouTube channel. That will give you a lot of basic tricks on how to use RoboDK properly. So here's the task for this one. So let's say that we want to inspect this simple part. One way of doing that will be to manually create robot targets or robot targets, right? That you come here, you reorient the tool, You say, okay, just like that, somewhere like this. And I'm just gonna create a first target. Then I'm gonna go forward, then create another one like that, and then so on and so forth. But that won't be super fast and that won't be super precise either. So there's a better way to do that. So let's bring the robot back to home. Okay, so if you go in the main menu and you click program, and let's say teach target on surface, by default, these two options will be activated, so add target and normal. So we'll stick to them for the moment. You'll see as soon as I'm gonna bring my mouse on the surface of the surface of the object, some kind of ghost robot and ghost tool will appear with a small TCP at the end. And as you can see, it's always try to keep itself normal to the surface here. So if I just like click, let's say right there, it created a target. I can click right here, it created another target. You can see those targets created in the station tree like that. I can come here, create those ones like that. And as you can see, in less time than it took me to create 2 targets the manual way, I already created 8 of those, and I'm sure that they are touching the surface and that they are normal to that surface. So okay, so that's great. Now we can create a robot program with those, so I can select them all. Let's just rename them first. So let's say part inspection. Okay, so it renamed the targets and it gave them a number. And if I right click, I can select create program, and it will create a program for me. I can right click rename or press F2 to simply give it a name, inspect part, let's say. And once I have this, I can right click on it and click generate robot program to generate the real robot program that I need to send to my robot controller. So just like that here, I have the 8 moves that I need to do here, and I have all the different position right here in the registry. So this is an AS file. This is meant to be uploaded on a FANUC robot. So if you've selected another robot, it will create a different file depending on the robot controller and the robot controller. In this case here, your robot controller for the FANUC may or may not accept the LS file directly. You may need to compile it to TP, so there's a way to do so. Once you created your targets like that, you can modify the position of them either by holding Alt, and just like using the different arrows to modify their position or the orientation. So this is an option to modify the position. Or let's say if I go to the second position like that, I can also right click on it and click option, or press F3. So just like that, I'll have this little window that will appear, and starting from here I can directly modify the values right here. So let's say that I wanted to have it directly on the edge here. I know that this part measures 600 millimeters, so if I go for 600, the new target is directly on the edge right there. So those are the 2 ways to modify the targets that were created by this feature. Okay, I'm just gonna bring that to the side. So this is fairly easy. So now let's go for a bit more complex example. So here I still have the same robot, the same scanner, and now I have some car transmission, the casing of a car transmission in fact. And let's say that I need to inspect this side here. So if I go for program, teach target on surface, and I bring the robot here, you can see that, yeah, I'm touching the surface, but the problem is that the orientation of the tool is not right, not even close. So it gives me a strange configuration and the robot is pretty much like destroying itself. So what I can do is use my left and right arrow, or up and down, same result, to rotate around the Z axis of the TCP, just like that, and create my new targets. I can create another one here, another one there. As you may have noticed, if you take a look at the, on the other side, the blue wheel here, if I'm using my arrows, the wheel here will rotate. So this is how you manage those. The red wheel will manage the rotation around the tool x-axis, and the green one, the tool y-axis. So I can create another point here. Again, it will always be normal to the surface I selected. So just like that, I created all the targets I needed to inspect this part here. But let's say that I do not want to be normal to the surface here. Let's say that I just want to keep the same distance all the time, but that I want to be like in the same orientation as this one for the whole inspection. So let's delete all of them. Let's go back to the first one. I go program, teach target on surface. Here, instead of using normal, let's use constant. So now it will just stay constant to this orientation like that. Even if I click on this surface here, the targets are really on the surface, but the orientation is the same as I defined here. Again, I click done like that, and now I have my program. So I can select them all, create robot program, and then I have my program just like this. If I delete all of those and I bring back the robot to its home position, so right click home, and I use the same process, so teach target on surface with the constant. Right now, as you can see, it's mimicking the orientation we have right now, so it's not necessarily what we want. So if you want just a small trick on this one, you just go with the normal for the first one, you adjust the rotation like that, you create your first target, you escape from this feature, this will create your first position, and you know the robot is now at this place here, and you can go teach target on surface again. Now you use the constant method, you create your targets, and then and then you have the result, the expected result. Okay. Next thing, let's say that we want to inspect those 4 holes right there. So if I go here and teach target on surface, let's say normal, and I try to like have a target right there. First of all, it's difficult because it's trying to snap on the inner surfaces of the holes. But even if I'm trying to be like right in the middle, it's hard to make sure that you're really in the middle and you are not keeping a constant distance with the outside surface, but rather with the inside surface, which is not necessarily what you want. So one of the options you can use to avoid that problem is here, the snap on arc center. So if you select that and you come just close to the external arc, you can press, you can click, and it will create a target right in the middle, just like that. Again, like that. And let's say here, I still have another one to do, just like that here. So in like that, just in a few seconds, I was able to create a robot program to inspect all those holes we have here. So that's great, I think. Okay. Let's say that now we want to, I'm just going to bring the robot back to home. Let's say that we want to inspect this line here and this line there. So if I go back to teach target on surface, I'm going to remove the snap on arc center, and I'm going to use now the snap on curve midpoint and edges. This one, as soon as you'll bring your robot close to an edge, again, you'll see the blue line appearing. And if you're close enough and you press, it will create a target right at the end of this surface. Same here for the middle point of this surface, so of this line, sorry, and here with the end, and let's create the end here, the middle point like that, and the end point just like that. Now this one didn't work because I selected the top surface, so right now the z-axis is pointing toward the bottom. So if I just click here instead, that would work like this. So again, I can click done, select them all, and create a robot program. And now, I forgot to rotate my tool before creating the target. So right now I'm not able to go upward as I'm hitting a singularity. So what I should have done is, like, again, teach target on surface, come here, and then rotate 180 degrees, just like that, create my first target, create my second one, my third one, fourth one, fifth one, and then last one. As you say, I don't need to be super precise for it to snap on the end. So if I just create the robot program, now I have the robot program that I required. Okay. There's another option that we can take a look at is the automatically extract surface corners. So by definition in RoboDK, surface corners are points on where 3 or more surfaces meet each other. So let's say here again, I can, let's say, just snap on the corner. Oops, I didn't activate it. So I can just snap on the corner. Don't need to be super close for it to work. So I could do that here. I could do that there. So for the moment, it gives me the same result. But let's say here that I want to have these here. So even if it's a curve, that's pretty much just a bunch of polygons. So here we have another corner. I can press minus a few times if I want to see things in a smaller way and create more targets. Just like that. This one is not right, as I selected this surface instead of selecting this one. I'm gonna go back to this here, that, like that. Let's say like this, that, and last one here. So just like that, I created 14 different targets. I can click done, select them all, and then right click, create a program. Yeah, so that works. Perfect. One last little thing that I want to show you here. Here you can see, let's say that we have those two lines here. They're not super close to one another, but still, let's say that I want to, okay. So if I come here, it select the upper line, and I don't need to go very far, so it select the one underneath it. I can press plus a few times so that you can see the normals in a better way. So I don't have a lot of room to manage here. And especially if you have smaller parts, that will become even more complicated. But if you go in Tools, Options, you will see in Display the Pick Curve Sensibilities. So if, let's say, I bring that to 1 and click OK, now I need to be way closer to the line for it to snap on it. It can be a good or a bad thing depending on the situation. Like I said, with smaller parts, it's a better thing to have those quite small here. I'm going to bring that back to its original value of 10. Click OK, and now we're done for this example. Let's jump to the other one. So again, same robot, same scanner. Now we add the Q bar from Creaform here in Quebec for the inspection. So this is an interesting setup where I'm just going to close that here, where the turntable is synchronized with the robot. So this way both can move at the same time in a synchronous way. And you have here the C track from Creaform again. This is here to keep track of where the Mitrascan is. So when they inspect that, they don't need to take into account the precision of the robot. They simply take into account the position of this with respect to the Mitrascan, and then all the parts that are scanned, or all the surfaces that are scanned afterwards, can relate to this position. So if I double click here, the program, the robot, sorry, you can see that, like I said, here everything is synchronized, so I can move here the turntable. So the only thing I want to do here is fairly quickly create a program to inspect all the holes we have right there. So to do that, again, let's say teach target on surface. I'm going to go for the snap on arc center. I can start from here, go there, 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 and then let's rotate a bit the turntable. Let's start from the bottom here, just like that. Oops, this one is not right. Just gonna go back to the last one, as it takes the orientation of the position of the robot right now to create the last one. Okay, interesting thing here. As you can see, you don't need to have a full circle. Just you have just a small portion of the arc that will create the target as required. So I could go there, there, let's say here, 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 and then let's rotate that again. There's not so many holes on this side, just a few ones like that. And then let's just do the last side of it, so just like that, just like that. Here, this one, this one, this one, and this one. I think we missed one here. And now we're done. So if I go back to a better point of view, I can click done, and I can create a robot program for that. And now it will inspect all the holes I have on the part, just like this. Okay, so that's great. I don't think this one is available. So this is great. So okay, so this is one of the other interesting thing you can do with the teach target on surface, but there's more to it. So here's the last example here. So this is a machining setup that I created, like I said, for a tutorials that I released this week. So here, if you remember from the getting started guide, there's a few things. If you want to create, let's say, a custom tools, there's a few things you can do. So first of all, you import the part, and then you need to set up where the exact TCP position is. So you can either double click on it and then enter the right values right there, or you can eyeball it by just clicking holding Alt and Shift, and then bringing it at the right position. But this is not super precise and not super convenient. So we have a better way of doing that. Go to Program, and then again teach target on surface. Here you have the Add tool. So the Add tool will pretty much just create a new TCP. So let's say that I'm selecting here by selecting the snap on arc surface. I can come here, create the tool like this. From there, I have two options. As you can see here, it created a tool snap. So I can just use that for my program. Or if I really want to have this value for the spindle TCP, I can open it by double clicking on it. I'm just going to go down here. And then I'm going to copy here, the button copy, and then here paste. And now if I just like hide this one, you can see that the TCP of the spindle is still at the right position, like that. So this was quite easy and fast, I would say. But sometimes things are not that simple. So let's say here in this example here, I have a drill bit at the end of the spindle. So this cannot simply be snapped to the arc surface because there is no real arc at the end here. So what I can do is, again, program, teach target on surface, add tool, and this time I'm gonna activate the snap cylinder axis. So what I'll do is I'll just like select this axis right here, just like that. And this way it will keep things along the axis of this cylinder. So here I created that. So because without it, I wouldn't be able to do so because of the drill bit helicoidal pattern. And again, I can double click here on the created snap tool. I can copy the value here, open the little spindle, and then paste the value. So both match together. If I delete the tool snap, now I have the TCP at the right position. So this was the first thing. Second thing is here. Let's say that I have my machining setup and I want to have the origin of the setup right in the corner here. So one thing I can do is teach target on surface, and this time I'm going to use the add reference. I'm going to unselect everything here, and I'm going to simply go right at the corner here. If I was here, I could use my arrows to change the orientation of the reference frame that was created, and I can click OK. And now if I want to, I'm going to click done. And now if I want everything here to go inside this reference frame, I can select the setup and the wall panel, right click, change support, and then frame snap. This way they won't move and they will simply change like what is the parent-child relationship between the parts and the reference frame. And now that everything is inside the frame snap, I can like move it and everything will follow together. So yeah, so that's it for that. Okay, so one last example. I'm going to go back to the second example I showed you. And this time I won't use the teach target on surface. I'm going to give you like a little small demo about the curve follow project. So if you go on utilities and curve follow project, it will create this, this window here. Let's say that I want to follow the line I was trying to follow before. So it took some time to go and select the different points and all. But here, if I go on select curve, and if the auto extract curves is activated, I can come close to the curve here. And as soon as you see the blue line, you can select, and it will select that curve. Now, as you can see, it will go from point 1 to point 2. Let's say that I want it to go the other way, so I can click switch sense. I can go auto select next curve. Oh no, I cannot because I didn't extract it. So I need to go clear near here. Can click on it, right click, switch sense. And if I go closer, I can, let's say, select this other part here. As you can see, I'm not able to select this section here, really. This is because of the other options I showed you before. So tool, display, and then here pick curve sensibility. So if I bring that down to 1, click OK. Now you can select the whole lines, and let's do the same here. So now I have this path here. So if I click done, by default, the curve follow project will create a line following this path. So if I update and simply simulate like this, so that's interesting. But as you can see here, the orientation of the tool is quite strange. So what I can do is I'm just going to need to showcase where the TCP is. I'm going to rotate the tool like this. I say, okay, this is kind of the orientation that I need. And I'm going to simply click on the teach button right here and then update and simulate again. And it will follow the orientation I just teached it. So again, I can, like I said before, right click, generate robot program. And then after a few seconds, the window will appear with the generated program for the find a controller with all the points to reach, just like that, and so all the move commands and all the points to reach below. Okay, so that's pretty much what I wanted to show you guys today. I hope you think it was helpful. Before switching to the question period, I'm just gonna play a small video that I pre-recorded, just the time for me to get a sip of water and take a look at the questions. So I'll be back in a few 2 minutes maximum. Okay, that's pretty much everything for today's webinar. If you think it was helpful, please hit that like button and subscribe to our channel. We will release more of those in the future. You really don't want to miss any of this. And remember, if you have any technical questions, you can reach us via the forum, so www.robodk.com/forum. We'll be happy to help you with your project. Have a great day.